Okay, cool. So I'm going to introduce Polycentric. And Polycentric is kind of like one of the backbone things that we're using with lots of our different applications as kind of a distributed backbone layer. So yeah, first I just want to talk about our some of the applications before we actually dig into it. So we have three main systems using it right now. One is GrayJ, our video app, which will be talked about a little bit later. One is Harpo, which is our identity management layer, and then the other is also called Polycentric, which is a microblogging system. So the kind of thought process here is even when I was a kid, you could go and use RSS and have one little application and synchronize all the different things across the internet at one spot. If there are all these different blogs I liked or podcasts I liked, I could open up my one little client and download them all. And things like RSS have kind of just slowly been dying off. Everything's been being put in different silos. Things live on Apple or Spotify or YouTube, and YouTube removed their RSS support. If I want to go and download videos, I have to do some weird kind of web crawling thing, and or maybe I can only get the latest 100 videos from that's all they generate for the RSS feed. And I really enjoyed that period of time where I didn't have to go and use 10 different platforms to get the content I liked. I could get my news, my podcast, my videos all on one little spot, and didn't have to deal with all the web tracking stuff and just jump around all the time. And also, one other thing that's about the past is that it was much more common for people to kind of self-host their own blogs. People would have their own WordPress instances, and they all had their nice RSS feed, and there are all these different places to get content. And for even just practical reasons, I think that's slowly kind of died off, and that people, having to self-host a server is kind of a lot of work, especially if you're a less technical user. You got to pay a little bill every month compared to Substack or Twitter or YouTube or whatever. Those are free to upload to, at least from the content creator's perspective. And so, in the case of GrayJ, we're kind of synchronizing. We have one video app, which for all the different video platforms, you can centralize them in one location. So we kind of made those services fungible. And with Harpo, you have all these different accounts on different platforms. There's dozens and dozens of accounts people have these days. You have your emails, you have websites you own, you have your blogs, you have your YouTube channels, you have all your different social media. Your half a dozen different social media companies, and it's a way to link them together. And then for Polycentric, we just have a microblogging system. And one of the other difficulties with most software is that even if you have something where anybody can run it, like your own WordPress instance, which tons of people do, all of your content still kind of lives on that instance. And for stuff that is going to be stored long term, a lot of times the big tech solutions are even more reliable. In that there's tons of blogs from 2007 I used to read that simply no longer exist anywhere. Maybe if I'm lucky, they're in the Internet Archive, but for the most part, there's just this maintenance burden of having to run those. And whereas there's lots of YouTube videos from 2007 or 2008 that people can still look. The famous zoo video, the first video on YouTube of the guy saying "Wow, cool, an elephant" or whatever. And so what we're trying to get with a system is a way so that all of your data can be stored on different servers that people run, and more than one of them, where you as a user don't have to do all that server management, but also you can have very low trust in the servers. And kind of we use this model to build everything. So what is a 1,000-foot view? The core of Polycentric is it's three main pieces. The first is it's basically a distributed database that you can run queries against. And the important detail of this database, unlike say Postgres or Redis or whatever other database you have, is that you can do queries against this database and be confident that the data returned is actually what the author wrote. So if you do a query against Postgres, for example, if the database was malicious, it could return whatever it wanted. And you really wouldn't have a good way to detect that. With this, there's a set of queries you can do, and let's say you want to look up in a key value store, for example. And you can guarantee that key was actually put in the database, and that it's not now an outdated view, or you could iterate over that collection and be confident that it's actually in the order the user put it there. But for lots of things that I want to do, I don't want the server to be able to manipulate anything. If I write a blog post, for example, the server shouldn't be able to edit that. However, lots of things are really fundamentally value judgments that maybe I do want someone else to deal with. So if I'm just writing my own content, let's say I make a movie or something and put it on the internet, obviously I don't want the websites manipulating that. But but there are lots of things on the internet that are value judgments, and in that case, these servers can also operate in that capacity. So if you have a list of things that are recommended to you, or replies to things that you've done, in those cases, if you're just interacting with your favorite 100 people, you reasonably can. You don't really have to worry about spam. You don't have to worry about them being malicious to you and filling up your replies with something terrible. But on the open internet, it's quite impractical to try to do all that spam filtering and stuff on your own device. There's billions and billions and billions of posts out there, and your local device can't possibly process all of those. So for small world, I feel like the public publishing to lots of people case architecture looks very different than the private case. For the private case, you want just your friends. You want end-to-end encryption. You kind of trust everybody a little bit, whereas the Polycentric stuff is almost all focused on the broadcast case and the kind of mass interaction. For the private stuff, we have apps like other FUTO apps like Circles, for example, and then there's also other very simple things, like if you want to count how many people like something. Well, if you have to go and download a message for every time somebody likes something and sum that up on your device, it's not uncommon to have YouTube videos that have billions of views. You can't count those locally. And also, what is a like? So if I want to make 10,000 on my own video, maybe other people don't want to see all 10,000 of my own likes. So fundamentally, somebody has to do these value judgments somewhere, and as part of the system, you can outsource that value judgment. So with databases, you kind of have the database 101 cap theorem, and so we're thoroughly in the availability and partition tolerance part. So you can publish all this data to these different servers concurrently. Also, to clarify, these databases, these nodes are run by different people. So I might have one database node run by one group I like, another database node run by another group I like, and use both of them concurrently for storing my data. And so as part of this, there's no fundamental global state. There's no blockchain stuff or anything like that. The servers all store different data. If you push your data, it's kind of more like a torrent in that sense. With a torrent, there's all these different nodes torrenting things. They all have kind of different views of the data, or what data is available, what's there. Yeah. Okay. So so if you want to use a distributed database, you kind of have to design your data models a little bit differently. So the core of all the database operations are called conflict-free replicated data types. And what that means is that when you store different things on different nodes, you as a user can merge those views together and get the same picture back. The most trivial version of this is, let's say you have a little counter. Well, if you add 3 and 2 and 2 and 3 together, you get 5 no matter what. The counter is kind of the most trivial version. So if one database has 3 and the other database has 2, I can pull those together. This also works for sets. If you want to add things to a set, you can do that and you just merge everything together at the end. It's a very simple operation. Or sets where then you can build up to more and more complicated cases, like sets where you can add and remove things. If you have timers, then you can see, is this thing supposed to be, is this delete newer than this write? And then have sets that you can add things and remove things from. And so conflict-free replicated databases have a little bit of are slightly limited in that not everything that humans might want to do can actually be expressed in a conflict-free way. It's very common in many applications to say, oh, everything uses conflict-free replicated data types, and so it's conflict-free. It's in the name. That means there's no conflict, right? It's in a mathematical model, it's very easy to call something conflict-free, but having that exactly mapped to what a user expects conflict-free to mean is a slightly more limiting case. An example of this is, any developers here will be familiar with get-merge conflicts. You could very easily resolve any get-merge conflict by simply overriding the entire source branch. That's conflict-free, right? I just automatically resolved. The computer resolved it for me. But of course, your code's not going to work if you do that. That's not the expectation you have as a developer. Fortunately, most useful things on the internet can reasonably be expressed in a conflict-free way. If I change my username, I want to use the most recent one. If I follow somebody and then unfollow somebody, wherever I last followed them, that's the one I want it to be. And I want to say, 95% of things that are useful can kind of fit under this category. And then when you start getting to complex documents, that's where things get a little bit harder. If you try to trying to do this for code, merging code together would be a little dubious. You really need some human judgment in that case. And with these data types, you can model stages where human judgment needs to happen, but we're going to make that explicit and not just kind of say, oh, it's conflict free. So we're kind of using the standard distributed systems terminology to all internally. So fundamentally, you have events, which as a writer of a system, you publish these events. I have my identity and I publish events. And that could be any arbitrary data. And that exists in a process, which would be like your phone. And then that will exist inside a system, which is just the collection of people that are able to write something. So when you publish some data to this database, it exists inside a system. That's just some public key. And then each writer has its own little identifier. And each writer then can generate events. And then these events are all kind of linked together with back references between each other. So even though I'm publishing on my laptop and my phone, the events that I publish on both those devices will back reference each other. So that if I, as someone querying this database, download one message from the database, from that message I can see, oh, there's all these other devices in the system. Because most things don't exist atomically. When you publish a tweet, for example, really that tweet outside of any context is not super useful. Or for a case like a movie, I might only want that movie. But for most data on the internet, it's somehow linked together. And so in our data structures here, we fundamentally link together, posts. Like posts, if you write a post or some message that you publish, it exists in this broader collection, which can be traversed. The next thing is that all this stuff is authenticated. So the most basic version, the most naive way to add authentication to something on the internet, kind of like PGP did in the 90s for email, is you have an email and you sign it and you send it to somebody. And again, that works quite well for cases where something is like fundamentally atomic. Like if you were to sign a movie, that would work very well. But for most data, if, for example, a feed like an RSS feed, for example, like this has an implicit ordering. I actually care about that ordering, and I want to be able to validate that when I'm downloading data, things are actually presented the same way. In addition to just signing the messages themselves that are sent out, we also sign all this indexing data. So if you use a normal database like Postgres or something like that, I guess that's my go-to example. You create B-tree indexes or what have you, and that allows you to, and in the normal databases, it allows you to do a query and not load literally all of the data. Because otherwise, if you don't have indexing, you just have to scan through literally everything and see what matches, and that's basically totally impractical on somebody's phone, especially for any large set of data. So we also publish, so in addition to signing the messages, we also include with every message this metadata, which could be a linked list or a B-tree or a hash map or what have you. And then when I actually do that query to the server goes and does the hash map lookup or the B-tree query or whatever, and then it returns just the nodes in the data structure that were signed that are related to that. And then I, as the user, can go and see, oh, here, even though they were searching 10 terabytes of data, I can go down this, I can see the exact path they took through the tree, validate those signatures, and it might be, five things that are signed. It's a pretty tiny amount to do a lookup. So you can very, very cheaply do that verification, even though doing the actual computation in the cloud took 4 terabytes of RAM and 50 cores or whatever they had. And so this is kind of a pattern of, attempt to make things, put expensive things in the cloud, but in a way where we can actually validate that they were done correctly. And then another aspect of, because we kind of have this multi-master distributed database with multiple writers and all the CRDT stuff, this kind of like by default works offline. Because there's not a global source of truth that needs to be updated for everything. If you write an application on top of this system, most things, all the core operations can just kind of fundamentally work offline. Like let's say I download a bunch of blog posts or something, I want to leave comments on them. Well, I can just go and write those comments to my database, and then when I come back online, things will be resynchronized. And this is kind of like almost an implicit free feature that comes out of this architecture. So when you're on your phone, you can browse all your content, and then even like things, dislike things, move things around, follow people, unfollow people. And as long as the data is there available locally, because you already have some of it, should all keep working. Almost every application is by default, there's like one source of truth somewhere that lives on one server, and if you don't have access to that source of truth, you can't really do anything without lots and lots of extra engineering work. And when you do the extra engineering work, it ends up looking very similar to this architecture. So one of the things we've built on top of this, and I think protocols are cool and all, but for the most part, people want applications, and we're trying to, with all this, kind of like build these applications first on top of it, instead of just talking about the protocol directly. So one of the things we have is Harbor, which we use, which is kind of we use to manage identity. And so in the 90s, it was very common to use PGP for sending emails and identifying yourself. You'd have an email address, and you'd have a key. And they had this really nifty idea called the PGP Web of Trust. And so when you have a whole bunch of people and you know them, you would say like, yes, this is my friend John's key. And then that information would get uploaded to a central database. Or it could have been multiple databases. And if you wanted to contact somebody, you could go look up their email and the address. And it's like all these people say this is the key for their address. And then be reasonably confident that they were who they said they were. Because there's this big problem with cryptography, which is frequently skipped over, that if something's encrypted, that's nice. But if you don't know who you're encrypting it to, it's kind of useless. If there's someone, if I think I'm chatting with John and I'm actually talking with Alice, okay, I got this nice encryption, but it's not really doing anything. So this kind of like discovering like what key corresponds to what person was one of the things that the system could have been used for. And the alternative to this kind of peer-to-peer way of validating people is like you have some authority. This is kind of the default way, in that there's like some authority that says, yes, this person owns this account, and that's that. And this is kind of pretty much how everything has gone in the last couple decades, is kind of removing this decentralized notion of trust, and instead of having trust be assigned by some large authority. So PGP was, even among developers, a lot of people found it kind of difficult to use. In the last decade or so, we've seen a big resurgence of trying to take some, things like end-to-end encryption, for example, and make it kind of as easy as possible to use, such the user doesn't have to like, where'd my key go? Which directory is this in? How do I actually sign something? Trying to explain how to actually sign something with PGP was quite difficult. And one of the other things with PGP is that, for the most part, you just kind of got uploaded to one of a small set of key servers. There wasn't like this automatic synchronization process. So we have one of our apps is called Harbor, and it's built on top of the Polycentric stuff for synchronization. And it lets you basically, you can make a key. It's basically a PGP key. Instead of like saying, I have a fancy key generation, it just looks like making an account. You press new identity, and you get one. And then importantly, one of the things, and then you can scan someone else's phone and kind of validate each other, or send links around and validate that, and that will get automatically sent off to the key server, similar to PGP, and then other people can kind of click around and view these webs. And one of the things I always thought was that was kind of unfortunate about PGP is that there, especially in the modern era, instead of being identified by your PGP key, you're frequently identified by all these different websites you have. Like your Twitter handle, your YouTube account, that's like the primary thing people know you by. So if we want to, try to get people away from having who they are being their YouTube account, we need a way to have someone demonstrate control over their different accounts. So inside the app, we have a list of verifiers or platforms similar to what Keybase did. And for these platforms, you can go and type in your username, and then through some challenge mechanisms we have, prove that you own that account. And then when other people click on your profile, they can see that you own this. We use this in the case of GrayJ, the video app. So with GrayJ, you have there could be 10 different video platforms that someone's on, and they're not fundamentally linked together. Whereas if with Harbor, because these are all integrated together, if someone goes and validates that they own their YouTube account, their Odyssey account, their Rumble account, and Vimeo, and whatever else they're using, inside the app, inside GrayJ, it'll show, this person owns all these different accounts. So from one UI, you tap on their profile, and it has them across everywhere. And then this is also published to a web interface, which you can share a link with somebody and then see, they've demonstrated control over all these things. Like I always thought that Keybase thing where I could prove I owned a Twitter and prove I owned a PGP key and all these different things was really cool. The platform support was kind of limited, and then they got bought by the video chat app, which slowed down things a little bit on their end. So yeah, here are some verifiers that we have. So inside the app, there's 9 that you can type in right now, and then we have and on the left we have, here's the actual code we have for verification. So I think this is the most extensive list of things that can be verified for any similar project. And what does verification look like? Well, there's a couple different ways that you can demonstrate control. The simplest way is if you have like a YouTube account or something, is that you could put a little string with your key in it in your bio. Then anybody that can crawl that website is able to see that, oh, these actually correspond to each other. And the other way is OAuth. So this is not, some websites, really make it difficult to crawl them, in that you'll be instantly IP banned, or they'll have all these Cloudflare or whatever anti-circumvention measures. For example, like Twitter is becoming like this. Some of the and then things like Instagram, et cetera, they really try to lock you down. But a lot of these sites have like official, login with X features, and you've definitely seen this, like login with Gmail. And when you do that, whatever you're logging into doesn't actually get access to all your email and stuff. It just, Google says, yes, this person actually controls this handle. And so the 2 types of challenges that we currently support are the one which is just, you put something in a bio and a web crawler goes and looks at it. And the other way is an OAuth. The nice thing about the web crawler system is that ideally, with all our stuff, we don't want FUTO to be the only authority which is able to operate. Otherwise, everything's kind of a total scam. So with, especially with the crawler one, it's very easy to have, if you want to have 5 different groups go and verify ownership of something, you just submit it to all 5 of them, and then that can all be done in parallel. With the OAuth one, you actually would have to go and say, okay, log in for prove to this one, prove to this one, prove to this one, which is a little more annoying. But from a user's perspective, it's very nice in that all they have to do is say, I just log in, and then it's all validated. And then of course the verifier then doesn't get the person's password or anything. It's all validated by Twitter or Instagram or Discord or whoever. So really try to make that as easy as possible end to end. So another detail is that about Harbor is that you can. So these are structured as things we call claims. You can claim something. In this case, it's ownership of an account somewhere, and you can also claim any arbitrary other thing you want, and people can choose to endorse it. But they're fundamentally kind of machine understandable. And then with these proof mechanisms, somebody on their laptop or phone could choose to go and do that crawling themselves if they want to validate it. However, in practice, having a web, if someone has a bunch of different sites configured, having someone go and and this in the case of a browser, it's literally impossible to go and have them crawl all these different websites and do all the validation themselves. So there's this bot we have in the cloud. And anyone else can run those bots too, and they'll go and like do this automated checking, and then give what we call a vouch, which says yes, this is true, or yes, I was able to verify this. And then when you load in your web browser or app that it's someone's profile, you can go and see, oh, all these different claims have been validated, and you don't have to go and crawl. As long as it's validated by enough people you trust, then or enough authorities that you trust. You don't have to go and actually like do all that heavy lifting on the device. So one other feature we have of the Harbor app, which is a recent one, is called the Harbor Gateway. So it's kind of almost like a login with Harbor feature. So you can, you have this key locally, and you can very easily with a simple handshake demonstrate control of a key. So what this looks like is someone sets up like a QR code somewhere. You can scan that with your phone, and then that's the entire login process. It demonstrates that you have control over the key. And then on top of that, someone can also add some criteria. So right now, the only thing that our automated scripts are verifying, again, anyone can run those verifiers, is that you actually own something. We'd like to extend this in the future to automatically verify more facts about particular platforms. So this could be something like, okay, only let somebody into this Discord room that has over 1 million subscribers on YouTube and 10,000 Twitter followers, or whatever other fact can be reasonably verified. And criteria could also be things that you and your friends verify with each other, but those ones are, I think, could be a little less popular because they're harder to automate. And so right now, it'll just let you get into anything that has a link to invite. So you can do like Signal group chats or Discord rooms or what have you. We want to extend that to more things in the future, but that's the that's just the basic proof of concept. And for sovereign identity, like proving that I am somebody, being able to just like tap a button on my phone, scan a QR code, and it's proven, is like I think about the simplest flow that we could think of. And this compared to a lot of the stuff, like technically, this is not a lot more advanced than PGP was, except for the data synchronization stuff. It's just really trying to make it, actually do the work to have all these automations integrate with it and make it as easy as humanly possible. So one of the other, so the Great J talk will be a little bit later, but I'm going to talk about the Polycentric microblogging stuff for a little bit. So again, the name Polycentric is also used for our microblogging platform. And for distributed systems, or for distributed stuff, especially in the peer-to-peer space, microblogging is actually can be a surprisingly hard problem, because in the case of microblogging, you're distributing data which is a few bytes. Most tweets are going to be 100 bytes or something. Mastodon posts, they're not big. And with most distributed systems, you have this kind of metadata overhead, where if, for example, if you imagine with torrents, when you start a torrent for a movie using a magnet link, let's go and do a DHT lookup. It might take a few seconds before the download even starts. Once it gets going for your whole Linux ISO or whatever it is that you're downloading on your system, then you can get very high bandwidth, but that initial synchronization overhead is very high. And if you look at a microblogging feed, it's like I got a post from this guy, from this guy, from this guy, from this person, from this person, from this bot, and they all have their own profile picture and usernames. And if you were to go and do a bunch of synchronization work for each of those posts, you're going to see, okay, this is taking a minute to load. So pretty much everything we focused on is doing, try to minimize the metadata overhead as much as possible to actually be able to deal with like small things that are written to very frequently, which is really kind of the opposite case for most. Again, this is more similar to a peer-to-peer application, even though we happen to be using servers. They just can't handle these cases very well. And then, some other problems with the social media that makes it hard is that, the data is very small, but you also have like many, many counts. It's a Twitter post can easily have millions and millions of likes and dislikes. And, having the infrastructure which can actually go and count those all correctly is important. And then we talked a little bit about the configurable authority stuff for these servers. So in addition to being able to specify multiple servers, in a microblogging context, if I'm following somebody, even if they're a spammer, for whatever reason I want to download their content, I should be able to download all the stuff that they have. But for for the people I'm following, for example, the people that I know, that I trust. But for most of the social media use case, a lot of times you're interacting with people that you don't actually know, or you're not mutuals. You're not both following each other. And in that case, if you don't have some mechanism for recommending and filtering, then the entire system becomes unusable pretty much instantaneously. It only takes one spammer to kind of drown out. One spammer can, with an automated script, make far more content than even millions of people can. In addition to being able to query multiple servers for actually doing your standard data queries, we've also made it so that you can do the same thing for like search moderation and like tallying and things like that. So normally, especially in there are other distributed systems like email, for example, where the federated model, where with email I can pick a server and then I have Gmail or Yahoo or whatever it is, and then send email to a bunch of other people that picked other servers. But if for whatever reason I don't like my email provider, or they don't want to do business with me, or they go down, what have you, picking that email provider was very, very, very expensive. So even though I can change what email provider I'm using by making a new address, I'm kind of stuck with, wow, everyone knew me at that one address. I'm kind of screwed now. I have to go and contact everybody else through some side channel and have them update that information. So even though in theory it's kind of like a distributed system, in practice it's very, very, very biased towards siloing yourself onto one particular implementation. Once I have my Gmail account, I'll probably have it for the next 15, 20 years, whatever it is. I'm not going to be in the habit of switching. So with some things this is quite easy. So for example, with search, if you want to do a full text search across all the tweets that exist, when you add multiple servers, they'll actually just all be used for the search process, and it'll tell you where the search came from. So different servers will have different content that they care about. They'll have different recommendation policies. And fundamentally, if I want to add or if I want to switch who's being the authority here, it should be very, very cheap. I shouldn't be locked in. Like if there's only one, then if I want to add another one, like a small upstart, it's very easy to imagine scenarios where there's one big search provider and then some little upstart comes by, but they don't quite have everything. You can't quite fully jump to them, and they just slowly grow. Or maybe the results just aren't good initially, and you just want to try them out. So you can add another server, and then it'll be added into your pool of things that are searched over. And if you end up not liking them, it's like very, very, very inexpensive. Like not only should you have the ability to change who you're trusting, you should try to make it as cheap as possible. Because right now there's lots of things where you can choose who you trust. It's just once you did so, changing off of that is just going to be a humongous task. Even right now, like with video sites, if I have YouTube and I can choose YouTube or Vimeo or whatever, but all my followers are on one of those platforms. All my likes and dislike counts, those are all on one of the platforms. They can't like interoperate with each other very cheaply. They're not literally the same platform. Whereas with this, because we have the consistent APIs, if you switch servers, or if you add 3 servers, when people are following you, they're actually going to be using, they're going to know about all of those servers. So if you decide you don't like one, you can stop using it, and then from your followers' perspective, they just get the data from the new place. You don't lose them. Same with search. Like if one of the search providers isn't good, you just stop using it, use another one. And trying to make like adding all these sources of trust like in a convenient manner is kind of the point of the microblogging demo. So what does this actually look like to use? So we have this thing called Polycentric Core. All this stuff is kind of built on top of that. And we kind of have this relatively simple declarative interface. So in this case, you're just like, using an example of someone like setting a username and a description. And, in the background, these are just wrappers where they go and create all the CRDT stuff. It does all the synchronization in the background. So from the user's perspective, you should just be like writing to some local store. And then in the background, it'll add all the information for like, how do I ensure this is tamper resistant? How do I assure that all the different servers get this? That when I add other devices on other phones, that they actually get all synchronized correctly. So the write path is kind of the easy case. The read path is quite a bit more interesting. So normally with a standard server, you have a request response, as in I go and ask my MediaWiki instance or whatever it is to tell me what the value of something is. In the distributed case, this is a little bit harder in that a lot of times this data can be updated. Like I might change my username multiple times. And different servers might have different views of this data. So when you do a query, these are actually kind of like dynamically updatable, and that it's kind of similar to a differential data flow in like theoretical database literature. And so if I do a query against like a list of ranges, for example, of let's say give me post from an hour ago to a month ago. All that data, as soon as it's available from some instance, will be returned to the client. And then if it's not all there, then the query manager will detect that, there's some integrity validation here and the data is not all complete. So you can read the data instantly, and then as soon as the server is or as soon as the client is confident that everything's up to date or complete, it'll tell you. It's very easy to imagine a scenario where I ask one server and they've chosen not to update. They haven't updated anything for months, so the username's super outdated. It'll give me that one immediately. And then as soon as the query from another server finishes, it'll all be stitched together. So we really we can't wait on a quorum of 5, especially for the microblogging case. When you click on something, it needs to load in 50 milliseconds, not 2 minutes, and we can't have a fancy quorum of unreliable servers to hold all the UI progress. But I think this is a decent middle ground. And then also from the client perspective, when I have a writer, let's say on my phone, I go and set a new username. Once that with a little bit of delay, that'll eventually propagate, and then this same query will then dynamically update and tell me, oh look, there's a new username. And so when you're building UIs and stuff, you just kind of attach these different queries to you write a different query for kind of each part of your UI, and then the system just kind of figures out, where do I get this data from? Is it from my disk? Is it from one of these caches? Has it actually passed all the integrity checks? And so it's a very like declarative query layer kind of on top of the system to try to make it a little easier to use. And this example is just querying for this could easily be a wrapper function, but this is kind of like more of a raw query for the latest CRDT value for a username. And of course, documentation is always kind of like a work in progress. But we have our repositories there, which can be, I think everything's under BSD3. You can go and look at the docs. Or I'm happy to answer any questions now. But that pretty much concludes the talk. Yes.
Two-part question. First part is, what open source packages are you dependent on? I'm not talking about low-level stuff like OpenSSL. I'm talking about higher level pieces.
Yeah, so right now, Postgres and OpenSearch for backend stuff. We use the server libraries in Rust. The front end is React and TypeScript. The Harpo mobile app is Flutter. But the most up to date
low level, pervasive kind of things.
Oh, do you mean higher level stuff?
Like what would be an example? Any big projects that are doing similar things that you're piggybacking on?
No, I mean pretty much our entire stack is standard developer stuff. We don't have any.
So the second part of the question is, what are the closest substitutes or fellow travelers in what you're trying to achieve here?
Technically, the two closest things have been Scuttlebutt and Hypercore. These were both Scuttlebutt. Scuttlebutt is really one of the coolest projects I've seen for a while. It was one of the big inspirations. Where the deal with Scuttlebutt is you had this sequence of posts, and you could write post 1, post 2, post 3. They were numbered, and then you could publish that data to whatever server you wanted. And there was this big disconnect between it didn't matter where your data was stored. So you could have a microblogging feed, and it didn't matter. And then clients could download that and be confident everything was there. Scuttlebutt had so it kind of has like all the properties you want, and that if someone doesn't want to host my stuff, they don't have to. Like if someone runs a server, they definitely shouldn't be forced to pay for stuff if they don't want to. But there's no cost. Like if somebody wanted to host something, it was strictly a value add, similar to seeding a torrent. Like if I don't want to seed a torrent, I don't have to. But if I do start seeding a torrent, then I'm only adding value to the ecosystem. So there's no big lock-in cost towards it. And the main thing that was difficult about Scuttlebutt was just a lot of practical stuff, in that in practice you were kind of expected to download the entirety of someone's feed. There wasn't a good way to do like partial queries against the system. It also didn't have a good multi-device story. Fundamentally, you kind of had, I got my feed on my laptop, I go and publish that, and it was at least for the longest time was kind of stuck there. But when you look at the properties that it had, they're exactly the properties I wanted to emulate. And that if someone tweeted 1,000 times, I could go and see, where is post 97? If one tweet was missing, you could see that. So I had this great full system integrity checking. But again, it was just kind of difficult to make practical at the time. And so basically trying to see okay, how do we make that work, but actually support multiple devices, actually support partially querying the data store. Like if someone has a million tweets, I shouldn't have to download all of them to actually do all the integrity checking for when I display my first screen. When I display my first screen, I should download just that data and be able to validate everything I need to just from that.